advanced stuff, random tips and tricks. To finish off this very long series of nuggets in Windows PowerShell, I thought I'd toss in just some of the little random side things that maybe you might not use every single day, but you certainly want to know what they are when you see them, and you will occasionally run into that odd situation where these are the things that save the day. Nice, lightweight, short way to finish up the really long series on Windows PowerShell. Now, this is truly going to be a random assortment. I plan to show you how to redirect pipelines. That's an interesting technique. There's the double $ trick, something called dot sourcing, which I'm pretty sure I've mentioned previously, but we'll cover what it is, and I'll tell you kind of the ups and downs from that. Also, some filtering techniques. This is really important. From a performance perspective, really. I'll show you 2 or 3 different ways, and I'm going to show you how you can test different techniques and approaches so you can see which one works best for a particular situation. So what I'm going to talk about now kind of is a mixed bag of applicability. Part of what I'm going to show you works in PowerShell version 1 and later, so version 2 and later easily, but there's a particular little bit of syntax I'm going to show you that is kind of unique to PowerShell version 3 and later. This is one case where we're kind of mixing and matching. I'm going to work in PowerShell 3, kind of the highest common denominator for this. So we're talking about pipeline redirection. Now, something that you may have run into, let's say I go to run a command like get content doesn't exist.txt, generates an error. Well, what if I had piped that to a file, test.txt? Error appears on the screen, and if we look at a directory, you can see that test.txt is a 0-byte file. So the error did not make it into the file. And that's kind of an important thing to understand. PowerShell has got various pipelines. Most of your basic redirection tricks only work with one of those pipelines. So this is syntactically equivalent, meaning it's the same as piping it to out file, and you get a test.txt with 0 bytes. So let's talk about those pipelines for just a second. Your first pipeline, and they are numbered, and you do have to just remember these numbers. Your first pipeline is the success pipeline. That's the pipeline. That's the pipeline that we're all talking about when we say pipeline usually. That's where the intended desired output of a command goes to. You've got 4 more pipelines on top of that. Number 2 is the error pipeline. Number 3 is the warning pipeline. Number 5 is the verbose pipeline. And 4 is the verbose pipeline. 5 is the debug pipeline. You'll notice that all of these correspond to different write commands, right? We've got write error, we've got write warning, we've got write verbose, we've got write debug. The other word I use for the success pipeline is the output pipeline, because we also have write output. So take a minute, grab a pen, grab a piece of paper, jot those numbers down, because you're going to need to know those. Let's see. I want to run that command again. The trick is, with this command, getContent is putting its output into pipeline number 1. Pipeline number 1 is the only thing that the angle bracket is picking up and putting into test.txt. Well, because the file doesn't exist, getContent isn't putting anything into pipeline number 1, and so there's nothing to go into test.txt. Modify the syntax slightly, though, and you can grab a different pipeline and put it into the redirection. So that 2 angle bracket says, take pipeline number 2, that's the error pipeline, and put that into test.txt. And so now we can see that test.txt contained this. In fact, it's probably easier even. Let's look at it in Notepad. There we go. So the error text, pipeline number 2, got picked up and put into the text file. There's another little trick you can use if you just want to get everything. Take all the pipelines and put them there. Oh, there it is in the background. So let's close that. I feel that I might have tricked you. So I got all the pipelines, including the error pipeline, by using asterisk and redirect. Okay, so that's a really, really useful, kind of a impossible to find out on your own technique if you don't just sort of compulsively go through and read the help files, because it turns out there is a help file on redirection, and it describes all of the different pipelines, there they are, 1 through 5, and all the different redirecting you can do. And this last one I'm going to show you is kind of weirdly neat. Let's find a file that actually exists. Dir star.txt. Do we have anything? Yeah, let's take that debug.txt. I have no idea what's in there. Get content debug.txt. Okay, that's fine. So here we're going to do. Content, I'm going to give it 2 files. Debug.txt and nope.txt, which does not exist. And I'll redirect that to combined.txt. Now this is normally a pretty cool, I wanted debug.txt, not ps1. This is normally a pretty cool trick. I'm getting 2 different files. I will put the contents of both files into the success pipeline, number 1, and I will redirect that pipeline into combined.txt. Now that means any error messages are not going to go into combined.txt. What if I wanted to get the errors and the content? One way, I already showed you, would be that. But that's going to grab success, errors, verbose, warning, and debug. It's going to grab them all. What if I just want the errors and the content to get combined? What I can say is, well, let's just type it because this is goofy looking no matter what you do. Take number 2, combine it with number 1, and that will wind up in combined.txt. Oops. No, it didn't. Because you can't quite use that exact same trick. Hang on. Let me, Oop, not right output. Now I'm all flustered. Right. Okay. All right, here's what I'm doing wrong. You know what? Let's draw this, because this is conceptually difficult, and this is where you'll get caught. So, all right, here's the thing. This command right through there is producing 2 different pipelines of output. You know what? Let's clear the screen, and I'll put that back up, and then we can talk about this. There. Now we can have an intelligent conversation about it. I got some room to draw. So this command is producing 2 things, right? Pipeline 1 is going to contain some text from debug.txt. Pipeline 2 contains an error message from attempting to read nope.txt, which doesn't exist. This operator is combining, so you know what? Let's draw actual pipe characters. Here's pipeline 1, and here's pipeline 2. This has some text in it. This has an error. That operator is putting this into here. But that's all it's doing. It is not implicitly piping, and that's the little character I'm missing to make this work. Once I've combined the pipelines, I still need to pipe the success pipeline, which is now where everything is, to something else. This works. Notepad, combined.txt. I've got the error and I've got the text output. Now you don't get to control the order in which these things get interleaved, so it can be a little confusing. But I think the reason you might want to use a technique like this is, let's say you're running a script as a scheduled task, and you're not there to see what error messages occur. Well, this is a way for you just to capture a raw output of what's happening so that you can troubleshoot the problem later. Of course, you could also use a transcript to do that, but not all host applications support a transcript. The ISE doesn't, for example. Whereas this is something that happens in the PowerShell engine and should be supported by any host. So that little redirection technique can definitely be useful in some circumstances, but it's very, very picky about the syntax, and it's a weird syntax. It's a lot of strange symbols. But whenever you see this, know that it means redirection is happening, and that you need to be looking at the about redirection text file, help file, if you want to figure out the rest of it. So, I mean, that's just a good little thing to key off of. All right, next. The next one is actually the double $ trick, and its companion, the $caret trick. Let's see. I just realized I said caret trick. Okay, let's just run a command. Get service minus name bits. Okay, the command ran, that's fine. $$ contains the last token of the most recently run command, and $caret, and that's above the 6 key on a US keyboard, contains the first token of the previous command. So these different hunks of the command are called tokens. This to PowerShell is one thing. This to PowerShell is one thing. So those are tokens. They mean something to PowerShell. It's one bit of information. This gets me the last bit of information. This gets me the first bit of information. Let's say we did, I'll show you what this does when you run things in the pipeline. Let's grab all of the services, run it to, oh, actually let's do this with processes. A little bit more to play with. We'll sort them on PM in descending order. We will run select object to grab the VM, the PM, and the ID, and let's also run -unique. Okay. What that did is less important than the fact that $$ includes the very last token of the last command that ran. $caret contains the very first token. So it's kind of a way for you to analyze, especially if you're constructing commands dynamically, for you to get a little bit of analysis into exactly what happened. Kind of rare-ish that you use those, but it's one of those things that you're gonna run across, and if you do run across it, I kind of want to make sure you know what you're looking at. So that's what that does. Next, I want to talk about dot sourcing. Let's open up a new shell, and I'm going to open up the ISE here. I'm going to write a little script. Let's just have this do something fairly simple. I'll create a function. Sort VM descending order, select the first 5. Nothing fancy. Let's save this C drive tools.ps1. Whatever. Doesn't matter. Okay. Close that. Normally, when you run a script, and this is something we talked about in the nugget on scope, when you run a script, it runs, it gets its own scope or container put around it, and when the script finishes running, everything that happened in that container goes away. So there is no function called my function. I ran the script, it defined my function, the script ended, and my function definition went away. If you look at the function drive, these are alphabetical, so it should be right here, my function, doesn't exist. Dot sourcing means you type a dot and a space, and then the name of your script. Yes. And it's going to run the script without constructing a scope around it, meaning the script is going to run in the current scope. Now, I'm in the global scope right now. I'm at the top level scope of the shell. So everything that happens in that script is going to affect the shell, the global scope, meaning that stuff shouldn't go away just because the script finishes running. Let's look at the function drive again. And there's my function. And I can run my function. And I don't run it as a script. You'll notice there's no path. This is just a function that is now defined in the shell's global space. Now that'll last until I close this window, and then it'll go away. So dot sourcing is, in one instance, or I guess in one sense, it's a way of including something from a script into another script, or in this case, into the global scope of the shell. The problem with dot sourcing, and the reason that as of PowerShell version 2 you see people use this less, is that there's no way to undo it. If I want to get rid of that function, I got to get rid of it manually. And if that had defined 20 functions, I'd have to get rid of every single one of them manually. So it's a little hard to do cleanup. Let's, oops, what was the name of my script? Tools. I'm going to put another function in here. So function, whatever, and we'll just have it run, I don't know, get WMI object, class Win32 BIOS. Just enough for it to do something. Let's close this. I'm going to dot source the script again. Yeah, I'm going to dot source it again. You'll notice I don't get any errors. It's continually redefining those two functions. So if I went in and changed one of them and I re-dot sourced it, it would load it right back in. I can run my function. Yep, there it is. I can run, what was the other one? Whatever. And it works. Del function whatever does not get rid of my function. So I have to clean these things up one at a time. So let's look at a slightly better way of doing this. Tools. I'm going to close this shell. Rather than saving if you start creating a library of tools and you put all these different functions into a script and you've got this little utility package here, rather than saving it as a PS1 that gets dot sourced, go to your My Documents folder, Windows PowerShell, Modules, create a folder for it. Let's say Utility Pack. In that folder, name it the same thing, Utility Pack, but with a PSM1 file name extension. This is a script module. We did this in a previous nugget. Here's why that's a good thing. Now, I don't really actually need to know where it lives. Because I've stored it in the module path, I can just run import module, utility pack. It will self-complete. It'll tab complete. I can run my stuff, my function, whatever. But now I can remove it. And they're gone. So, well, okay. Because of PowerShell version 3, it auto-loaded that when I ran. So I don't even have to manually import it, but I can remove, I'll show you that this does work. Remove module utility pack, dir function. You see there's no whatever and there's no my function. If I try to run whatever, it'll go find that lives in the module. It'll automatically load everything in that module. There's my function, there's whatever. And you can see it lists them as being in utility pack. So that's a better way of bringing things into the shell than dot sourcing. It's more automatic in PowerShell version 3 and later. This whole technique still works in PowerShell version 2, and it gives you the ability to load things into the shell and remove them from the shell. So that's all very, very useful stuff to know how to do, and a lot cleaner, I think, than using just dot sourcing a regular script. Now, this last bit, this is going to be kind of a twofold approach here. The purpose of it is to, I guess, at first highlight that there are differences in different ways PowerShell does something. You've seen throughout this entire series that anything you can do in PowerShell, you can do 3 other ways in PowerShell. But that doesn't necessarily mean those ways are created equal. And I wanted to kind of take a moment here to highlight an area where that's particularly true, and to show you how you can figure out on your own which way is better for a particular circumstance. It's going to involve testing. So let's do this. Because a lot of these performance differences are really imperceptible when you're dealing with a small number of things, I'm going to artificially deal with a large number of things. So I'm going to use the range operator to produce 10,000 number objects. And then I'm going to pipe those to for each object. And in its process block, I'm just going to multiply each one times 5. We're really just trying to do something. So that's one approach. Here's another approach. I'm producing the 10,000 objects, but I'm storing them in the $range variable. So now they're in memory, they're stored in memory. And then I'm going to run through them using a for each construct. And we'll just take each item and multiply it by 5. So we're doing the exact same thing. What's different? Which one do you think will run faster? A lot of folks don't know, but here's how you can find out. Measure command. And you just kind of wrap your entire command in this thing's script block. And then we'll do it for the second one. There we go. Now, because I've asked this to do 10,000 things, I really am not interested in the actual math here. I'm just going to pipe all of these to null. And so long as I'm doing this consistently and both things are doing the same thing, we're still going to see a difference. So I want to point out, we don't need to save this. I want to point out that the actual task we're doing, taking 10,000 objects and multiplying them by 5 and piping the result to alt null, that's happening the same in both cases. So we're not going to see any differences based on what it is we're doing. The differences we see are going to be based on how we do it. In this case, we're generating 10,000 objects, putting them into a pipeline as they're being generated, and passing them through to for each object. It's going to process them one at a time. In this case, we're generating 10,000 objects and storing them in a variable in memory, and then looping through that array one at a time to do the math. Now, I'm going to do these separately. So I'm just going to comment that one out. I'm also going to get Task Manager up and running. We're going to put this over on the side here. And, oh man, does it need to be that big? Good. Let's go find PowerShell. PowerShell ISE right here. So I can highlight that, and we can see its CPU, its memory, its disk, and its network. Let's make it just a little bit smaller. There we go. So pipeline way first. I want you to notice that we're starting off at just under 50 megabytes of memory usage. Here we go. All right, we ran up to just over 50 megabytes of memory usage, and this took 780 milliseconds. So I'm just going to write that down. We wound up at 50.9, and it took 780 milliseconds. Now let's go back in. I'm going to comment the first one out, so that's the one we just ran. And now we're going to uncomment this one. All right, we're back down to about 48.8, 48.7 megabytes as our starting point, and now I'm going to run this again. All right, that took 671 milliseconds, and we didn't use very much memory for very long. We went down to less than we had before. .NET probably did some garbage collection, but it looked to me, let's run this again, it looked to me like we peaked at like 50.1 or something like that. 50.3 was maybe our peak. So in this case, this one was actually a little faster, and I either used a little bit less memory or about the same amount of memory. Sometimes it's a little hard to tell. All right, so let's comment that out. I'm going to leave both of those there as kind of models. Now I want to work with some objects. What's a good way to do this? Well, you know what? Actually, we can probably, our ability to measure time with measure command is fine enough that I think we can probably do this with just maybe process objects. Measure command, get process, pipe, for each object. And the process block here is going to be, let's take the VM and the PM and output that. All right, so the ISE looks like it's sitting at 55.9. Let's run this. We went up to 56.5 and took 23 milliseconds. Okay, now let's go do this the other way, which would be to put procs in a variable and then use a for each proc in procs. So now we're using the second technique. So we're at 54.8 megabytes. That took 4 milliseconds. It's even quicker. As you start to get more and more objects going, you will notice that the performance on these two different styles changes. Because this one does not require you to hold all 10,000 objects in memory at the same time, it is able to process them one at a time. This requiring you to hold all of them, we start bumping numbers up here. I'll show you. Let's take out the comments. Put a couple more zeros in here. And we're going to run both of those. And this is obviously going to take it a little bit longer, so we're going to have to be patient. Look at the ISE over here. It's spiked out. 100% CPU. It is multiplying by 5 as fast as it can. Memory usage, I'm not paying so much attention to because we're doing both of these techniques at the same time. So I'm going to get the cumulative memory impact of them both as they run. Let's give this a second. Okay, my first one has completed now. It took 597 milliseconds to do this. So let's wait for the second one to finish. Notice my memory has spiked up to 84.8. So now we're seeing the second one come at us. And actually, I should say that was, so this first one, now we've got them back to back here. The first way, which was the pipeline way, was 53, stop scrolling, was 53 seconds and 597 milliseconds. The second way was 33 seconds, 952. It was much, much, much faster. So my point is that between these different techniques, it's important for you to measure them in reality. And Measure Command is a way to do that. It's important if you want to fine-tune your performance that you do some testing. Sometimes you will be driven to a particular technique not because it is the most visually attractive, but because it's the one that gets the job done the fastest with the data you are dealing with. So a grab bag of techniques for our final nugget together on Windows PowerShell. We looked at redirecting pipelines, the double $sign trick, showed you a little bit about dot sourcing, showed you some different filtering techniques along with that measure commandlet, really useful for testing different techniques if you're interested in the performance and how they can differ between them. I hope this has been informative for you, and I'd like to thank you for viewing.